Okay, cool. Sounds like it's working. Today I'm going to be presenting on my graduate capstone. I will be honest in saying this is a preliminary, or like, this isn't my final presentation. I'm using this as a little bit of a dry run. With that, this is probably more professional than most of my normal presentations. Likewise, it kind of deviates at the end because I needed to get some stuff done. But yeah, so Compscore by me. So first off, talking about who I am, I'm Max 4.0, whatever, bunch of stuff I do. You guys know the drill. So introduction. What is Compscore and why do we need it? So let's first start talking about offensive and defensive cybersecurity competitions. Some might know it as red-blue competitions. Most people know it like that. But my paper says offensive-defensive to sound more professional. So generally, red-blue competitions, competitors, being the blue teams, all face off against a red team, which you get into a battle of defending and degrading infrastructure. You're trying to uphold your services that are getting scored. Red team's trying to take them down. And then this back and forth and this standardized way of all competitors competing not against each other, but against a centralized authority creates a red-blue competition. So with this, competitors are scored on several facets beyond just what we talked about. That service uptime is ping. Are you able to ping boxes? Authenticate to FTP, get a DNS resolve. There's also stuff like business tasks called injects, which try to emulate what it's like to be an actual business scenario, deal with stuff beyond service or beyond business tasks. And then there's also others like COF that you see in ISTS and like professionalism. There's a ton of stuff. So scoring engines become this it becomes absolutely core to the competition. Without having a standardized way to score, it's anarchy. The original competitions for red-blue competitions had something called the green team. Green team, they were people on a laptop saying, hey, can we actually get to this person's web server? Can we actually authenticate? The first ISTS was exactly that. We had a couple teams sitting around in a circle, and then there was an entire extra team that all they did is mark down in a spreadsheet, yes, it's up, yes, it's down, and that would later be culminated into scoring. As many of you can see, many of you can imagine, it's not necessarily a very good way to do it long term. So then we started with scoring engines, the automatic service uptime checking. So this allows for a single source to automatically and most importantly consistently check services. So what happens if you have a freshman on that green team who, or honestly, how I've seen, could even be like a graduate student fourth year, but someone who doesn't know how to properly FTP or log into a domain box via command line, well, that team gets hit and their score will suffer because of who's scoring them. So scoring engines allow us to have a standardized way to score everyone in a competition. So within this, we have the requirements of being able to detect status of several different services, quantify service statuses into a score. So actually being able to have a score to say who won and what place they came in, display live statuses of all services. Because again, those original red-blue competitions, you didn't know until the end of the competition what was happening. There's no such thing as a score. It was at the end, they aggregated that spreadsheet and they figured it out. And allow user interaction to edit those services. So change passwords that are being checked, such and so forth. So currently, we are at a state of there's no good options, but all the options are good enough. So there's been little innovation because why rewrite it when it mostly works? So these scoring engines, we'll go into them specifically, but they all lack critical things. So these are anything from lack of documentation, difficulty or their inability or difficulty to use them or deploy them, inability to integrate to other parts of the competition, which become vital when you're creating a very well put together competition, and then also resource constraints. having to deploy larger and larger competitions just to scale properly, or to you're hitting scaling constraints. So let's talk about those scoring engines that we were talking about before. First off, ScoreStack. By most measures, this is one of the best scoring engines out there. I would also like to note the scoring engines I will be talking about are publicly, freely, and openly available to everyone. So there's plenty, like CCDC has their own custom one they rolled. I won't be talking that because I don't have any personal experience with it, nor do people who don't ever compete in CCDC. So ScoreStack, it's a Golang based scoring engine. It uses the Elastic Stack to store as well to have a front end to that database. Its benefits is that it's extremely fast scoring. Golang itself lends itself very well to multi-threading as well as multi-processing, allowing for really streamlined performance, as well as the Elastic Stack. In everything that it does, it is built to have really good graphing capabilities and is extremely flexible as well as stable. Cons, as anyone who's dealt with it, it's inactive. It's not actively developed upon. It's built every year or so. It'll get a PR to fix a new issue that we find, and at this point, we've squashed enough of those bugs that it's decent. Next, complex deployment. You're looking at Elastic Stack, which by a lot of means is an absolute pain to deploy. This is meant for enterprises, and it's got a lot of those same techniques involved. And for something as simple as what a scoring engine should be, it does not scale properly to that. As well as Elastic Stack versioning errors. This has been fixed semi-properly with CI/CD, but there was years where we were unable to deploy ScoreStack for weeks because of versioning errors, just because Elastic Stack updated. And then lastly, it's resource intensive. We'll talk about later, but I'm pretty sure in a comparison of Compscore versus ScoreStack, I use a quarter of the resources. Next, scoring engine. This is the predecessor to ScoreStack, and it is a Python full-stack scoring platform. Benefits are right there. It is a single language. It's all built together, but that also comes with some serious constraints. So while it has extremely straightforward development and configuration, as well as it has a decent amount of graphing capabilities just to bolster itself, still hits inactive development. UI is completely unreactive, coming from Flask templates. Slow scoring, Python really hits constraints, and anything larger than a couple teams will really slow it down, and it is pretty resource intensive at that. Lastly, something that I didn't know about until I started really looking, DSU DevSec, the Dakota State University, actually made a mock scoring engine, and it's honestly pretty decent. So Doinator 5000, it's a Golang full-stack scoring platform. It's built just to have a team or two. It is not built for something like IRSec, ISTS, CCDC, but it does stuff really well. Like it has built-in inject capabilities so that you can read and submit injects all in one place. That aligned with very simple deployment, simple configuration, as well as genuinely fast scoring, puts it at an advantage unlike others. But again, it's not a scalable solution. This is built for a very small competition. And it does have some development. Most of its development is more recent, but it's still pretty inactive. And lastly, it's, as you can see, the front end is fairly simplistic. So from all this, we can abstract some goals. First, for a baseline scoring platform, we need to be able to support several check types. We have to have a stable scoring engine, and what I would prefer is a minimalist UI. A lot of the UIs from these scoring engines are either way too complex or way too little. I believe you should be able to do what you need to do best and then build off there. So next, being developer focused. I want something that's pluggable and modular so that you're not making PRs to a main project that you really don't have any control on just to change stuff for your competition. Likewise, straightforward configuration as well as development, being able to accelerate that stage where you're going from I have nothing to I have completely running scoring engine. Next, we need to extend past scoring. We need to be able to, as Dwayne and Nader did, integrate injects to CDC, as well as integrates injects, as well as different types of scoring beyond that. And just to be adopted, you need to be better and significantly better in order to get people to accept your new product. People aren't going to change just because there's a 1% difference. You need to be the best in order to move people over from something that they're familiar with that may not be the best to the best. So we're hoping to make a solution that is here to stay. And with that comes all this. So let's talk about my specific implementation. So one of the biggest things in terms of project structure is Compscore is not a single repo. There exists a main repo, which is the entire scoring engine, and then there exists the check repos. All previous scoring engines existed that every single different score check was just a different file, and then you imported those. Instead, Compscore, you can take any Git-based repo, name a function, and have that instantly runnable inside of your scoring engine. So you no longer have to just insert your own code into your scoring engine anymore. You build your own repo, maintain your own repo, and then you can use that for years to come. Next, configuration. A lot of the configuration so far with the previous scoring is there's a lot of files, there's a lot of places to put stuff. I condensed it down to two. First, there's config.yaml, which this will describe your individual competition. How many teams are there? What checks do they run? How are they weighted? Stuff like this. And then your .env file describes your deployment. Are you doing production or development? What port should it run on? What's the domain that it hits? And then lastly, when we're talking about components of this, there's three. There's the scoring engine, which will actually do all the scoring, hitting boxes saying, hey, this is up or down. Our API, which is an extremely robust way of being able to integrate past just the front end, but also give a really reactive front end. And lastly, the front end, what users are actually being able to use and hopefully enjoy. So first off, the scoring engine. This is the heart of Compscore. It schedules checks, retrieves results, handles the API, as well as records status. There's a bunch in there that looks really intense, and honestly, this is the most complex part of the project. At any given round, where rounds are just a sequence of ways of grouping checks so that you can say every single service for every single team has been run, it will spawn hundreds, if not thousands, of Go routines, which are the single most smallest level of concurrency for Golang. Within this, we have components like the check scheduler, which will actually be spawning all of those Go routines that will do those checks, as well as reading them in. Code generation, as we talked about before, we're able to dynamically build in new checks from your own Git repos. So this is done through code generation. So Go is a statically compiled language, so it doesn't mean that you can dynamically compile new things in, but what it does mean is that we can have something that's able to generate dynamic code that can be statically compiled in. So by configuring your checks, you will automatically compile new code in that will then be included within the project itself. Your API, which is able to access all this, as well as provide your front end all the information it needs. And lastly, a database connector, which completely abstracts whatever kind of database you're using. So first off, check schedule. We're breaking scoring into rounds. So when you're going through, round one will be the first round you ever have, and it is able to represent at that given time or increment what checks have been up or down. So each round has a delay where all these score checks are performed. Checks are spawned, most importantly, checks are spawned based on check and not team to not give advantage of like team one, team two, anyone early getting more time. So, and then they evolve down from being spawned to scoring to waiting to close. And once everything's closed, we can then finally log everything, and produce a new scoreboard for the front end. So we see a little bit of what's going on here, where I think per check you're spawning around three go routines, with a bunch of other overhead. Next, the scoring engine code generation. So as we talked about before, Golang cannot dynamically import code. Technically, if you want to get technical, you can. It just sucks. But Golang really sucks at it. And it was something I tried, and it actually became almost physically impossible to do it how I wanted to. So we have the solution, code generation. We dynamically build the code based on what we want to import, and then we're able to statically compile and import all that new code. So checks are pulled in from the config.yaml, and we can actually see a small format here where you simply put like the name of the check, where to find it, and then all the configuration for the check. And then it just works like that. Next, the scoring engine, the API. Currently, it supports over 30 different endpoints, JWT authentication, as well as inline and interactive Swagger documentation. The other really important thing in the API is much of it is unauthenticated. I found as previously on Black Team that I wanted to do some integration with the actual scoring itself. I wanted to be able to take the score and give teams points to spend in the store. Score stack, it's impossible. The API itself is just not there to do anything other than tell if a single check is up or down. And it's all internally stored, and there's a whole bunch of issues that come with trying to access it. So instead, we provide anyone the ability to access everything from scoreboards to rounds to users, checks, and statuses. So that makes it extremely extendable for any third party. Next, the database. There's a complete ORM abstraction built for it using ents. That means fully annotated and typed schema based on Golang structs. So that sounds like a whole lot, but it basically means you can write code and it just automatically becomes queries. And for a developer, that's huge. Not needing NoSQL when you can just like say, hey, I want a user that looks like this, run it. And it just will. Likewise with that, you never have to worry about specifically how to query different databases. So SQLite 3 and Postgres and MySQL and MS SQL, they all have different facts of syntax. Now, we really don't have to care. That's all abstracted by Ent itself. And then likewise, the development version that we'll talk about before is entirely thread safe because SQLite is not thread safe. But and there's a whole bunch of stuff other than that. We can see a small bit of schema just for how everything's rendered and built to be as efficient as possible. So let's talk about the front end. So new project coming out that's been extremely popular is Vite. I built this project entirely in Vite along with React, TypeScript, and MUI components. Likewise, for further integration, every single scoreboard that exists has an iframe so that you can integrate it into your own tools. So theoretically, if you wanted to, you could have Compscore. You could have a little iframe in the top right that would show your exact scoreboard or your team's scoreboard, and you never have to flip to a new page. Theoretically, hopefully in the future. But we see a ton of this. I'm not a front-end designer at all, or did any front-end before this. So all this was brand new to me. I am looking to go back and fix a lot of it and make it way nicer. But even as is, the minimalistic approach, I believe works. Next, deployment. Everyone knows the importance of deploying at the correct scale. When you're in development, Compscore supports two types of deployments, development and production. So when you're trying to get all your checks up, make sure that everything's working, there's development, where everything can be ran in a user shell, everything can be stopped and started really quickly, and it supports just very basic. Next is production. Your far more intense version, I would say. Completely Dockerized, building in front-end, back-end networks, caching servers, production databases, as well as reverse proxies that do automatic, ACME TLS certificates. And overall, it runs fast, it runs consistently, and you can get a lot done with it. And talking a little bit more about that configuration from before, we have our two, I was supposed to say .env, not production. We have our two types, config.yaml. It's an extremely simple thing where we're able to describe users, teams, scoring intervals, and everything, followed by all the checks, which then get independently put in and updated. Next, the .env file, where we can see all the different things that can be described, such as the port our web server is running on, our secrets like passwords and JWT tokens, everything from Postgres configuration to Redis configuration to everything. So you can deploy entirely new comps, entirely new scales, just based on your configuration. So there's not much in terms of results so far, but there is one. If you guys didn't see, it was actually running in the background the entire time during RITSEC. Overall, it worked really good. Deploy, stability, configuration, front ends, they all worked seamlessly as much as I hoped. And not to say that there weren't hiccups that we'll talk about in a sec, but it worked very well. So hot patches, day of deploy, I did several things to make sure that Compscore was working, was integrating performance of the competition, as well as a ton of things. So some of the checks, I was never actually able to test them because it's not too often that someone has access to an SMB box at home. I tried and it became too much. So instead, this was the first time testing things like SMB, LDAP, and some others. And more than likely, they worked pretty consistently. And the hot patches made them perfect. Then query efficiency. During the original deploy, we were querying scoreboards, and some of them were taking upwards of a minute. And that is really scary when you consider that when something's taking a minute but takes 30 seconds to actually run around that you're supposed to be able to query from, it's an impossible pursuit. So night of, I went through, we did a complete data rework, and we moved from the over a minute query to I was doing twice as many rounds at less than half of a second. So extreme efficiency and cutback, and we got it all working. So this is not without its flaws. There's still a lot to be done. Currently, I'm working on some GraphQL integration so that we're moving away from REST and doing something far more efficient. Next, WebSockets for scoreboards. The scoreboard's by far the most resource-intensive part of this entire thing. You have to query a ton of data and aggregate a ton of it as well. So building in WebSockets so that you can automatically publish and subscribe to scoreboards only makes that more efficient. Next, a full front end rework. I'm not a front end developer, and if I were to go back, I would redo a lot of it and fix a lot of it. So I'm going to do that. And lastly, more admin features. Currently, it supports stuff like starting and stopping competition from the UI itself, changing passwords, doing temporary and full authentications from an admin user. But I want to add a lot more, like being able to edit users' checks, such and so forth, so that realistically, once you deploy, all you have to do is go to the admin panel and handle it all. And then the other three big things that I want to do, first is cost integration. Currently, cost competitions are scored with the same thing as red or blue competitions, but instead of saying you have 10 cost boxes and so there's 10 checks, it depends on the amount of teams because they just repurpose the same red-blue competition so that each of them have a different scoring index or different token on those that will check against what you need. So if you have 15 teams and 10 places or 10 different cost endpoints, that's 150 checks instead of realistically what should be 10. So there's going to go building into that, as well as injects integration. There's no reason why we can't be integrating all the portions where scoring comes from into the same thing. We saw Reina do an amazing job with this, and I'm going to only further that work. And then lastly, proxy support. Forever, one of the biggest issues with red-blue competition is something called spirit of competition. We are trying to emulate what should be a realistic network, but it's impossible unless we had something way larger at scale. We were doing public endpoints, such and so forth, a ton of stuff. And so what ends up happening is people start noticing, hey, all of our team's on this single subnet, or everyone's getting hit from this one box. Let's just block that. So what we can start doing instead is using proxies, so that theoretically, if we wanted to, every single red team box could also be a scoring endpoint. So you couldn't just block an IP. Something that you really can't do in the wild without affecting customers. So there's a ton of stuff to do, and I'm really excited to do it. Lastly, this seems like a really simple project, and I thought it would be a super simple project. It ended up not being. Just in terms of the code itself, we're approaching about 30,000 lines, and if you actually look at my GitHub, it's like the proudest I've ever been. I think today is like 79 days in a row that I've been like committing, and this project is just like finally nearly done before I like rewrite it all. The main repo, we're currently sitting around, I think it might have fit 600 commits from yesterday. And then just in terms of total changes, it's around 90,000 lines. I did a lot of work on this. I'm devoted to making it a hell of a lot better, but I just don't want to understate how big of a task this ended up being. I'd like to lastly leave it off for questions. Chase.
What initially inspired you to create Compscore?
So the initial inspiration was, I think, last ISTS. We've run ScoreStack for, has to be 4 or 5 years now, and that's been our scoring platform of choice for a while. And Braden, the scoring lead at the time, just could not get it up. It was just not working, and we kept questioning, why do we even use ScoreStack if we run into the same issue every single year that we can't figure it out? Lo and behold, we actually figured it out, and we actually wrote documentation on it, and it's kind of fixed now. But it was this like moment of realization. I'm like, this could be something that actually is able to affect something, actually be able to do something worthy. There's so many graduate capstones as well as capstones that are legitimately just projects that get thrown out as soon as they're presented, that I wanted to do something a little bit more meaningful, even though it might have been like 5 or 10 times the work. Sure. So one of the biggest efficiencies over ScoreStack is the fact that it's not using ELK. So ELK, Elastic Stack, is very robust, and if you're working in an enterprise that has thousands of different places where you're supposed to be getting data, it's a great thing to use. When you're running a competition for 8 to 12 hours and you need something running and consistently scoring, it's probably not the best choice. It was originally used because ELK was the craze when it was created, so they wanted to follow up on that. So the biggest efficiency here is the database management, as well as creating a way more efficient front end, and that part makes it way more efficient. And then likewise, the other really big thing is the fact that we're no longer looking at a giant monolithic repo for all of our checks. So anytime that we needed to do edit a score check, we'd have to make a PR to the main to the main repo of ScoreStack. It would take a couple months for someone to realize, even after we bother them every so often, and it would be a pain. Likewise, something I completely forgot to mention, the other really good portion of having those like separate check repos is we can now have tagged and versioned checks. So if for some reason the newest release breaks the SMB check, you can just revert to the previous and it will automatically deal with that. Likewise, if you want to just have, for whatever reason, the ISTS 24 check of FTP, and you only care to use that one, you can do exactly that and specify that target. So there's a whole bunch of improvements. Largest one is just bringing it is not a complex issue, and we've built it into a complex issue. So simplifying it all and building something proper and bespoke to the issue. Anything else? Otherwise, I know that there's a ton of great presenters today, so I don't want to take up any more time. Awesome.